Hello and welcome back guys to our new video of rank of matrix. In the last video we have learnt about rank of matrix, how to find rank of matrix. But that's not enough for university exams or GATE or UPSC exams. So let's deep dive into some theory. And in the last we'll see an example, okay, of how questions come in college exams or GATE exams. So let's start with some theory of linear independence. Okay, so linear independence. Suppose there are three rows, row 1, row 2 and row 3. But row 3 is R1 plus R2, that is row 3 is row 1 plus row 2. Row 3 is row 1 plus row 2. Then we can say that row 3 is dependent on row 1 and row 2. Okay. Similarly, if row 3 is k times R2 equal to elevator, okay. So row 3 is some k times R2, then also row 3 is dependent on R2. So this is linear dependence, okay. We have to remove linear dependency to find rank of matrix. We always try to find linear independent rows or column, okay, to find rank. So let's look at row echelon form. Okay, in the last video we have learnt about how to find rank. So we are trying to row reduce to find rank of matrix in the last video. So that is row echelon form, or we can also say that row reduced form. Okay. So what we do here, okay, so let's understand this. The first point is move rows with all entries 0 to the bottom. So what we are trying to do in the last video also, we are trying to move the row with all entries 0 to the bottom. Okay, so we'll try to move any row which is all entries 0 to the bottommost point. Okay. Second is leftmost column with a leading non-zero element must be right to the above non-zero row. Okay. So what we are trying to do, suppose we have taken column 1, there is a non-zero entry in row 1, so we are trying to keep it as the leftmost, and any non-zero element in the next row should be in the right of it. Or we can say that if row 2 has a leading non-zero element, then row 1 must be to the left of it where there is a non-zero entry. Okay. Third point is entries in a column below a leading non-zero element must be 0. What we are trying to achieve, if a column has a non-zero element, leading non-zero element, then all the entries below it should be 0. We have seen it already yesterday. Okay, so let's move to minor form or determinant form also. We can also say minor method. Or determinant method. Okay. So minor method or determinant method. Okay. Suppose there is a 3 cross 3 matrix. Okay. And we are trying to find the rank of it. If determinant of the matrix is non-zero, then the rank will be the minimum out of the rows or columns. Okay. If determinant is 0, then what we do? We try to find a matrix which is just below that. Suppose there is an n cross n matrix. Okay, and determinant of n cross n is 0. So the rank can't be n. So we try to find a matrix which is of the order n minus 1 cross n minus 1, just one below it. Okay, and we try to find if it has a non-zero determinant. Any matrix formed out of n minus 1 cross n minus 1 should be non-zero. Okay, if it is possible, then it becomes the rank, that is n minus 1. If it is also 0, all the possible matrices are 0, then we try to go n minus 2, n minus 3, until we find a matrix which has determinant as non-zero. Okay, so let's see. For example, I am taking a 3 cross 3 matrix. Okay, suppose 3 cross 3 matrix. This is a 3 cross 3 matrix. Let's find its determinant. Okay, it is 1 times 4 minus 6 minus 2 times 2 minus 6 plus 3 times 2 minus 4 is minus 2 into minus 4 plus 3 into minus 2 is minus 2 plus 8 minus 6. This is 0. So the determinant of a 3 cross 3 matrix is coming out to be 0. So rank can't be 3. Okay, so we try to find a matrix out of this matrix. Okay, a matrix inside it such that its rank becomes 2. We try to find a 2 cross 2 matrix because 3 minus 1, the next number is 2. Okay, so let's take example of, suppose I am taking this matrix. Okay, suppose 4 6 1 1, I am taking this matrix. Okay, let's find the determinant of this. So determinant of this will be 4 minus 6, this will be minus 2, that is non-zero. So we have found one matrix of 2 cross 2 such that determinant is non-zero. So the rank will be 2 because it is a 2 cross 2 matrix. Okay, so its rank is 2. Rank of A becomes 2 because we have found a matrix of order 2 cross 2 such that its determinant is non-zero. Okay, so that's minor method or determinant method. Okay, so let's see some properties of a rank. Okay, let's see some properties of rank. So the first property is rank can also be represented through this symbol. Okay, row. So rank of A is less than or equal to minimum out of m comma n. Rank of A will always be the minimum of m comma n, whereas m is, what is m? Number of rows and it is number of columns. Okay, suppose A is a 3 cross 5 matrix. Okay, so rank will be less than or equal to minimum of 3, 5. Minimum of 3, 5 is 3. So rank will always be less than 3. Okay, this is the first property. Now, let's see at the second property. Rank of A transpose will always be equal to rank of A. Okay, we all know what is A transpose. Okay, now look at the third property. Okay, if rank of A is 0, then A is a 0 matrix. In any other case, if A is non-zero, then rank of A can't be 0. Only in case of 0 matrix, the rank of A will be 0. So this is our third property. Let's look at the fourth property. Okay. Suppose there is a n cross n matrix. Okay. There is a square matrix of n cross n. Okay. And determinant of A is non-zero. Okay. A square matrix with determinant non-zero. Then in that case, rank of A will always be n. Okay. We will use it widely when we will deal with linear equations. Okay. In coming videos, we will deal with linear equations. In that scenario, remember this one. It will help you. It will help you a lot. Okay. So that's for properties of rank. Okay. So let's look at some problems. How questions come in exam. Okay. So they will not generally ask of rank. Okay. They will ask something like this. Suppose there is a matrix. Okay, there is a matrix. They will ask, find K such that rank of A is equal to 3. Okay, we have to find the value of K such that rank of A becomes 3. So we know how to find rank. Just we have to go through that. Okay, the same process. So what we will do? We will see at the leftmost column. The leftmost column is this one. We have a leading non-zero entry. Okay, that is 1. So what we will try to achieve? We will try to make all the entries below it as 0. Okay. So let's make all the entries below it 0. We'll copy the first row as it is. Okay. How to make row 2 0? Row 2 goes to row 2 minus 2 times R1. Then the leading element will be 0. Okay, so let's do it. 2k5. Okay, minus 2 times row 1, that is 1, 2 and 3. Copy this 2k5. Take this 2 inside. 2 to the 4 and 2 to the 6. Okay, so 2 minus 2, that's 0. This is k minus 4 and 5 minus 6, that's minus 1. Okay, so let's copy this here. This is 0, this is k minus 4 and the last one is minus 1. Okay, similarly let's try to make this as 0. Okay, because all the entries below that leading non-zero element should be 0. So how to make this 0? What we will do? If you subtract row 3 by row 1, it will automatically become 0. So let's do that. Okay. So what will happen? 1, 4 and 1 minus 1, 2 and 3. Let's subtract 1 minus 1, 0. 4 minus 2, that's 2, and 1 minus 3, that's minus 2. So it is 0, 2 and minus 2. Okay, that's all. Now we have made the leading column as non-zero and all entries below it 0. Then we move to the next column. Okay, but we will skip this row. Okay, so we'll start with here. It's a k minus 4. We have to make sure this is non-zero. Okay, and we'll try to deal with other things. Okay, so k minus 4 is non-zero. That's for sure. Okay, now how to make 2 as 0 so that k minus 4 will be non-zero. Okay, so what we can do, okay, so if we divide, see, this is 1, this is 2, this is 3, this is 0, k minus 4 and minus 1. We'll copy this row as it is. We have to make this 0. Okay, so let's do it. I am taking row 3 as row 3 minus 2 times, yeah, let's do this. If k minus 4 is non-zero, okay, this implies k is not equal to 4. K is not equal to 4, because if k is equal to 4, then 4 minus 4 is 0. Okay, then 2 by 0, that is not defined. So k can't be 4. That is, okay, k can't be 4. So if we divide by this will become 0. Okay, minus 2 plus 2 times k minus 4. This will be is minus 2k plus 10 divided by k minus 4. Okay, so we have solved this. Okay, so we have already made the entry below it as 0. So we'll move to the next column. Next column, we'll skip row 1, row 2. Now look at this element. This should be non-zero to make rank 3. If it is 0, then rank will be 2 because all the entries here will be 0. Okay, so this should be non-zero in order to make it rank, to make rank 3. So what will happen? Look, minus 2k plus 10 by k minus 4 can't be 0. It can be other than 0. It can be anything. 1, 2, 3, anything. Minus 1, minus 2, minus 0.5, anything, but not 0. Okay, what does this mean? This means minus 2k plus 10 can't be 0 because k is already not, k can't be 4. Okay, so this is non-zero. Okay, so the upper numerator can't be 0 because denominator is already non-zero, because k can't be 4. Here we have taken the condition already. Okay, so what will happen to this? Minus 2k can't be minus 10. This implies k can't be 5. Okay, so let me rewrite it here. Okay, so we have already understood this. You have taken copied this. Okay, so let me erase here. Minus 2k plus 10 by k minus 4 can't be 0. Since k is already not 4, k is not 4, so denominator will never be 0. Okay, so what it means, that numerator will be 0. Okay, so the numerator can't be 0 also. Okay, because denominator is already non-zero, so numerator also can't be 0. If P is not 0 and Q is not 0, then the P by Q always is non-zero. Okay. So what will happen to this? Minus 2k is not equals to minus 10. Okay. We'll take 10 this side. This is minus 10. This implies k can't be 5. Okay. K can't be 5. And we already have a condition k can't be 4. And now we got the condition k can't be 5. So we have to take k other than 4 and 5 to make the rank 3. So what will the answer for this? K can be any real number except 4 and 5. Okay. So k can be any real number. This is for real number, we represent it like r. Okay. Real number can be represented with r. So k can be any real number except 4 and 5. This is except. Okay. We are subtracting 4 and 5 from the real number. Okay. We are puncturing these 2 points, 4 and 5. Okay. So k can be anything else except these two, 4 and 5. Okay. They can't be 4 and they can't be 5. So that's all for today. If you learned something, if you liked the video, go share, subscribe and like the video and comment for any problems which you will face. We will deal with it in the next video. Okay. Or I will make a separate video dealing with all your queries. Thank you for today.